Then when x is equals to what? 2, we have y is equals to 5 minus 3 into bracket 2, which is equals to what? 5 minus 3 times 2 is minus 6. Is minus 6. So that's why we have minus 6 here. Is equals to minus 1. So it is these values that we are now going to use in plotting our graph. Now we'll be plotting our graphs after calculating all, getting our values for our y, and then we've been given the values for the x, and then now we've gotten our values for y. So we'll be plotting our graphs. All you need is just to get your graph booklet, and if in the exam hall you'll be given your graph sheet. So what you just do is just that you draw your y-axis, and then this are y-axis, our y-axis, and then our x-axis. The horizontal line is our x-axis, while the vertical line that I've drawn is our the vertical line is our y-axis, and this horizontal line that I'm going to draw is our x-axis. Our x-axis. Now, here the highest value in our x-axis for our x, we have maximum of 3 and then minimum of 3. Mind you, this is our origin, and then if this since 3 is our highest value, we can just say that let 2 centimeter represent 1 unit on the x-axis. So we can have here as 1, 2, that is after 2 centimeter. After another 2 centimeter, we have 3, and then 4 after. So the space in between each unit is 2 centimeter. Minus 1 on the negative side of the graph, we have minus 2, and then you have minus 3, and then minus 4. But on the y-axis, the values we are having up to 14 on the positive side, which are at the top, and then on the negative side we have minus 4. So that's the reason why I have chosen to leave more space at the top, that is at the positive side of the y-axis, while on the negative side I have left little space, because more space is being required for our y values. Now for the y, well, I'm taking 2 centimeters to represent 2 units, that is 1 centimeter to 1 unit. So I'm having 2 here, 4, 6, 8, 10, 14. Now on the negative side, that is below our origin, we now have minus 4 and then minus 6. You see that all the values we are having for the values of y falls in between this, and then the negative side also falls in between what we have on the graph. Now we'll now take it one after the other. When x is equal to minus 3, our y is equal to what? 14. So you just take your ruler and then make sure that it's parallel, and then you make a mark of a cross or plus. Then when x is equal to minus 2, y is equal to 11. When x is equal to minus 2, y equals 11. Our 11 is here, so we have something like this. When x is equal to minus 1, y is equal to 8. Minus 1 is equals to 8. When x is equals to 0, y is equals to 5. Y is equals to 5. When x is equals to 0, y is equals to 5. So it's here. And then when x is equals to 1, y is equals to 2. Y is equals to 2. When x is equals to 2, y is equals to minus 1. When x is equals to 3, y is equals to minus 4. So after now we've indicated all the points, now we'll now join all the points together. Now bring your ruler. You bring your ruler. You set it in such a way that all the points fall on the line, or majority of the points fall on the line. So what we are now having is a straight line through which a straight line that passes through all the points. Can you see? You can see that all the points that all the points we are having on the graph pass through the line, which proves that this is a linear graph, a linear equation. And then the last part said use the graph to solve the equation 5 minus 3x is equals to r. That is when our y is equals to r, what is the value of x? Now we now trace that, this 1, and then this 1, and then we'll now check for when x is equals to half, when y is equals to half. When y is equals to half, that means 0.5. If these are 1, this is 0.2, 0.3, that half simply means 0.5. This is 0.2, 0.4, then this is 0.5. So we'll now trace that to our line, to our graph that we plotted. And then we'll bring it down. So from here, we can see that for that equation, that is question 1c, we can say that our x is equals to, when x is equals to 0, y is equals to 0.5, our x is equals to 1.5. That is if you are to solve from this graph, 5 minus 3x is equals to half. Now, from here we can say that 5 minus into brackets 3 into brackets 1.5. If you should calculate it, we'll see that it's the same thing, because 3 times 1.5 is 4.5. 5 minus 4.5 is equals to what? Half, which is equals to 0.5. With that, we've solved the questions related to linear graph. Now we'll now be taking quadratic graph, which is just part of what we are doing. The former one was just an introduction to, so that we'll just familiarize ourselves to plotting of graphs. Now we'll now be using quadratic graph in solving quadratic equation. Now, a quadratic function of x is an expression in which in which 2 is the highest power of x. That is, a quadratic function of x is an expression of x in which 2 is the highest power of x. For example, 3x squared minus 5x plus 1 is a quadratic function of x where 2 is the highest power of x. The parabolic shape obtained while plotting is obtained while plotting a quadratic graph. That is when we are plotting a quadratic graph. Let's say we are having something like this, and then these are 0. Most of the time we have something of this nature, or we might be having something of this nature. Our y-axis, our x-axis. That is, once we have a graph that looks like this, either this or this, it shows that this is a quadratic graph. When the coefficient of x squared is positive, the parabolic shape looks like this. That is, when the roots are positive, when the coefficient of x squared is positive, we have something like this. And when the coefficient of x squared is negative, we have something like this. And what we mean by coefficient is when we have something like maybe ax squared plus bx plus c is equals to 0. When a is positive, this is what we have. When a